like we rewrote the programs and things, but we still didn't know like what would happen until it actually happened.
That's what
And
they need to talk about in
then
history.
it happened, and life went on.
That's what they need to talk about in history
Huh?
books.
Did you believe it?
Did I believe all of the hype?
Yeah.
No.
See, that's what I wanted to hear about in history books. That people were just stupid.
How? They're just stupid.
Well,
Like,
see,
I don't know what number comes after those.
uninformed people, well, we just call that ignorance. And some people use that with a negative connotation, which it really doesn't really have to be that way, because just because you don't know something, I mean, it might not be your fault that you don't know something, but you are ignorant of that information because you just don't know it. But people use it in a derogatory form now. Say, oh, you're ignorant. Well, I mean, it might not be their fault, but they just don't know. Anyway.
why do you think it was going to end in 2012?
That was the end of the Mayan calendar.
Because they didn't know how to come back from
No, 2012. We're talking about 2012.
Yes.
End of the Mayan calendar.
Yeah. But they came and went. They actually made a movie about it.
Oh yeah, I saw that.
Well, they made a movie before it actually happened, because they were expecting this to happen. Aliens and the end of the world and lots of fun stuff. But it came and went, and now we're at 2024, which is great. Yeah.
I
Yes.
feel old.
2012. I think the name was.
2012.
The movie was 2012. I think before 2012.
All right, here we go. So let's take a look at, let's say we have an object going around in a circular path. Okay, we're going to assume that r is constant. And remember, for our projectile motion stuff, that we can draw the velocity vector tangent to the curve. So if the ball is going in a circular fashion like this, let's say that this is a top-down view of a ball going around in a circle on the floor. Okay, so like, you know the skip it things? Like it's a little loop that you put your leg in and
I
you,
used to love those.
okay, and you look real dumb when you do it, but it takes some skill to do it, so yeah.
I love those.
Yeah. So this is a top-down view of that. So the ball is going to go around and around at a constant speed, okay? So I can draw my velocity vector tangent to the curve, like that, okay? Now, at different points in the path, the velocity vector, well, now it points to the left, because again, it has to point tangent to the curve. Where do you think it points here, when our ball's here?
Down.
Down, you guys got it. Right. And when it's here?
To the left.
To the
No,
right.
wait,
To the right,
Yeah,
yes,
right.
because we are going, again, in a counterclockwise fashion, like that, good. Okay, so if we're going at a constant speed, does that also mean we have constant velocity?
No.
No, why not?
I just wanted to
I mean, you're right,
Oh.
absolutely, but why? Inquiring minds want to know.
Because gravity.
Air resistance,
Gravity.
everything. Velocity does have a direction, because it's a vector, right? Yes.
My bad.
So
was right.
the velocity, although it's at a constant speed, we're not speeding up or slowing down, but instead we are changing direction. And what happens if we have a change of velocity?
Acceleration.
Acceleration, yes. Yes, remember,
So smart.
our acceleration is defined as the change in velocity with respect to time. Yes. So if the velocity is changing, then we have acceleration. Now, up to this point, we've only talked about how if the speed part is changing, then it's going to have an acceleration based on if we're going to speed up or slow down. We learned if the acceleration and the velocity vectors are pointing in the same direction, the object is going to speed up. If they're pointing in the opposite directions, the object's going to slow down. Okay? But we never really talked about, well, what happens if the object changes direction? Now we do. Okay? So, the real question is, where does the acceleration point? If it's supposed to go with it to speed it up and against it to slow it down, it has to be some other direction.
Yeah.
That way?
Yeah.
Well, thankfully, we can actually find out exactly where the acceleration vector is. Let me kind of show you here. Although we don't necessarily have numbers, that's okay. Let me
Shut up.
write that guy down here because we're going to use it later. So when we have, so let's assume that we start here, and a certain amount of time later, it's going to be here. So we've got our velocity vectors. I'm trying to draw them the same length. So this is our initial velocity and our final velocity, just for the sake of making things easier. Okay? So if I want to find the direction of the acceleration, I need to find the direction of the change in the velocity, because the time is the scalar. That's not going to help. Okay? So now remember, this is going to be the v final minus the v initial. So wherever this vector points is where my acceleration points. Now remember, we can add vectors together, but we really can't subtract vectors. But we can add the negative of a vector. So if I do, well, vf plus a negative vi, that'll do the same thing. And what does the negative of a vector do?
Change opposite direction. Opposite direction.
Well, we're talking graphically. So I can't draw a picture subtracting vectors. Okay? But rather we add vectors using the head to tail method. So using a graphical method, I can't subtract vectors, but I can add the negative of a vector, and you guys are right, the negative flips it around. Same size, opposite direction. Okay, so if I'm trying to add together my VF, I'm gonna bring it over here. So here's my VF, okay? And if that's my VI, my negative VI will be equal and opposite, like that. So I'm gonna put that right there. I'm gonna draw it head to tail, negative VI, and start where I started and where I finished. I'm drawing my resultant, and my resultant, that's going to be the change in velocity. Notice where it points. If I were to superimpose this back onto the average of the two positions here, where does it point?
Perpendicular.
Towards the middle.
Isn't that what I said? How did he say that?
Okay, which is why we call this a special kind of acceleration, centripetal acceleration. Yes, so the centripetal acceleration always points towards the center of the circle, and this is an acceleration not because we're speeding up or slowing down, but rather because we're changing direction. Yes. Okay. Now, centripetal, if you wanted to know, is actually Latin for center seeking.
Why?
Center seeking. There's another something here, you might have heard it before, centrifugal or centrifugal force.
It goes against.
Yes.
It goes against the force.
We'll talk about that in a few minutes. Yeah. All right. So we've got our centripetal acceleration. So that's always going to point towards the center of our circle. Our velocity vector is always going to point tangent to our circle. Now's a good time to take 5, and then we'll come back and finish it out. Don't want to sit on that. Yes. You just did, but you can ask another one.
I'm so sorry. I know I ask you so many questions all the time.
Yeah, don't be sorry about asking questions.
It's his job.
I don't know which one's which, but they're both crunch. Give him
You just
I'm guessing this is
superimpose it back onto because
The difference between this,
probably.
or is that yours?
so if this is your V initial, this is your negative V initial, because it's the same length but opposite. Oh yeah, sorry. So if you wanted to match what we've done before, we could just call it U instead of.
So these two this.
Well, no. So we took our V final, so a little bit distance away.
Yeah.
So our V final points up like that. So that was this vector. And then I'm going to add the negative of my VI to that. And then that's our change in velocity.
one side, you can move it, and then on one side.
Cool.
Thank you.
Yeah, I think we're cooked because like I was just so hot in November, bro.
Yes. So did you hear they're making a second Moana?
Oh yeah, comes on.
It's gonna be dog.
And a third Incredibles. They're making a live action Lilo and Stitch.
They just don't want to stop.
They're making a fifth Toy Story.
End it.
I thought it was done at 3, so.
God damn, this nigga crushing me right now, bro.
I didn't actually see 4. Yeah, it was good. Yeah.
I can take it out.
Because he needs money. Because this is why you're seeing so many like refreshes of things and sequels.
Wait, which one?
It's because people in Hollywood now have no imagination.
No, but what's the fifth one?
Because all of the new stuff that they try to make
It's bad. It's all
is
bad.
crap. Like there's no
Including
new
the Star
ideas. They just revert back to, oh, well, let's just remake this great story and make some more money.
Most of it isn't bad.
Ain't that what Star Wars really is?
You know the
That's why Star Wars is not good.
all the
You're partially right there.
It's remaking. They don't know when to stop. It's literally cash grab.
See, they're not just remaking the same story. They're using a good story as a jumping off point
For 100
doing
different
other
ones.
stuff. And some of the things that they jump off of do quite well. Like, but then some of them don't. Like for all of the Disney Plus shows that they've made so far, only The Mandalorian has actually gained like really good popularity and done real well. But all of the others, like the Book of Boba Fett, the Ahsoka show's not bad, but it doesn't have the same like yes as the Mandalorian show does. So like they try but some just don't hold the attention and are really well written than others are.
Why can't they just make an ending?
What's up?
Why can't they just make an ending?
Make an ending? Because there's always more money to earn.
It's just a cash grab.
I mean, yeah. I mean, you don't make a movie to, well, let me say this. Most people don't make movies just for goodwill. Most people
You don't do it to entertain.
Most people make movies because they're trying to make money.
I know.
They'll make toys and sequels.
Hey, where you doing?
All
No,
that.
he gave him $1 for that. I wasn't selling it. I was just giving it away. It was my bag.
okay, I'm actually out
Because I just don't sell Pop-Tarts. I bring it for lunch, but I never eat it. I never eat it. You want Pop-Tart next one? I gotta get it already.
That would make sense. And then there's the issue of the live action the mermaid.
Oh no.
Like,
I'd rather go.
some people like the fact that they use a black girl, and then some people are like, but you're messing up the original story.
I'm gonna say this.
Alright,
There's some movies that are, I guess, I know it's also
GRGC used to be sold for $1.
but,
So you like,
I mean, I'm not mad at it,
Oh,
but
wow.
it has that.
Wait, so it's a lot.
But there was
They both
we were
suck.
talking about,
They
like,
both
return.
suck.
Okay. Black. It's just no one talks about it. A lot of people are some racist Yo, if you change a white person in a movie, like say you got a broke with a white person, they change to a black person, black people will be flying on that. When you change a black person to a white person, what the
Oh, like the Little Mermaid?
Because ears, they go green.
Yeah, I don't like.
Should have kept it white. That's what but if I said that out loud,
Like, you
you go get jumped.
Like you say Winnie the Pooh, you see him coming out.
I'm saying it's like you just. I remember that Winnie the Pooh Button Honey. That thing was.
Watch them make Moana black. No. What?
She's an islander, but like
She's an islander.
Yeah, but she colored. You're not black. I sure colored.
she's black.
Basically.
Yeah,
I can get away
I
from
do
an
like
islander.
how they cast the new,
No, they had a black
the
one.
live action.
They do.
It's not old.
Like that was well done.
It's the only way.
Yeah.
I got it wrong.
Right.
Cinderella is the story. Is the story.
They made a black
Snow. You got a good point. You got a good point.
Well,
All right, guys, break's over. Let's get back to business.
There's still Snow White. I don't know why they call it.
Okay, so we know our velocity vector points tangent to our curve, and we know that our acceleration, the centripetal acceleration, is going to point into the center, making a right angle between the velocity and the acceleration vectors. So, and again, this is only because we're changing direction, because this is all based on constant speed. Okay, so the centripetal acceleration is based on changing direction as we are going on a circular path. So we've got an equation for that here, and it is in our A2, right at the bottom here. Our centripetal acceleration equation is going to be v squared over r. So you take your speed, you square it, and divide it by the radius, and there you go. The units work out. There are different forms of the centripetal acceleration, although technically they don't give you an a sub c, they just give you the a. But you're gonna remember that that's actually centripetal acceleration because of the r, the radius of the circle. There you go. Okay. Now, but how do we find the speed of an object going around in a circular path? Let's focus on that for a few minutes. Okay. So if we were to, like, let's say that I'm swinging my ID around in a circular path, and I wanted you to find the speed of it. You guys don't have a speedometer. You can track how fast it's going. So what can we measure, possibly, to calculate the speed of the object?
Distance from the middle.
Distance of what?
From your hand.
Distance from my hand to
Lanyard.
the ID. Okay, so the length of the lanyard. All right. What else can I measure, Jordan?
The amount of time it takes for one full circle.
Ooh, now that's actually a special term, isn't it? The time it takes for one complete circle. What do we call that?
Revolution.
Slope.
Slope.
Fun.
Slope.
Did you say period?
It's slope.
Close enough.
It's period. Good job.
Period.
Period.
The period, yeah. So the period. So it looks like a T.
What is
That
that?
looks like an
It looks like a T. It's actually tau.
This
It's
is
another Greek letter.
You just making up stuff now.
No, it's not.
You're making up something.
You can be making this stuff up.
These are actual Greek letters
No.
that are actually used in
I don't like
physics.
this period.
you always
So the period is the time for one complete oscillation. So it's not just time, but it's the time for one complete cycle. Okay?
You gotta write amen.
Now,
You're telling me that there's an actual symbol for that?
yes,
Amen is my only symbol.
yes. Now, in most cases, what you'll see in a text or in your equations is just a capital T. But it's actually tau. So whenever I write it, I add the little gutters that says, hey, this is actually tau, the period, and not to be confused with like temperature,
How do you spell it?
which is capital T in English. Okay, so just Just roll with it, all right? Now, if we were to calculate the speed of the object, the speed is typically just, distance over time, right? So if I knew how far it is from here to here, and I knew how much time it takes to go from there to there, I could calculate it. But it's really difficult to measure the time for just a quarter of a circle, but it might be easier to measure the time for one full length of a circle, which would be the period. Okay, so I'm going to use the period here.
T.
Now, what would be the distance traveled in a full circle?
Radius?
The root, the diameter.
Circumference.
Circumference!
I was right.
Yes, the circumference. And what's the equation for the circumference?
Pi r.
Pi r squared.
Pi r, there you go, 2 pi r. The pi r squared is the area. Yeah. But remember though, that there are certain mathematical equations in the front of your equation sheet, like the area of a triangle. If you have a brain fart and you forget that, it's right here. Okay? The area and the circumference of the circle, right there too. There you go. See? Boom. As well as your constants and prefixes, all sorts of good stuff.
Do we get to have this on the AP exam?
Say what?
Do we get that, the sheet on the AP exam?
Well, you'll get a different sheet because technically this is for the IB exam.
Do we get to know what the AP exam looks like?
Yes, and factually,
And factually?
and factually, I like that. I'm going to use that more often. And factually, I posted on Rooms just this morning, so you have a copy of the AP equation sheet as well.
You're on it.
I try to be. Right now, I'm going day by day. Day by day. All right, so this is one good way that we can calculate the speed of an object that goes around in a circle. We gotta measure the radius. We're gonna multiply by 2 pi, and then we're going to divide by the period, or the time it takes for one complete circle. Okay, good. Now, remember though that there was a link between the tangential velocity, v, and the angular velocity, omega. So if we look at our equation sheet, our last equation on A2 is this. The v is equal to 2 pi r over tau, okay? But it also has the equals to omega times r. So it's on there. Yeah, and we can use it. Say that again. I know. All right, so now that we know what the v's are, let's plug the v's into the centripetal acceleration equation, because there's 3 different forms of the centripetal acceleration equation based on what kind of v we have. We have our basic v, that's our first one. Okay. If we're using our omega, then we're going to have our acceleration look like r times omega squared. Okay. And then if we're using our period here, it's going to look like this. Our AC is going to be 4 pi squared r over the period squared.
At mercy.
And that's all in your equation sheet. They're just all in a line here. So based on what the problem gives you, notice that all 3 of them have r in it, but this one has the tangential, or the along the ground speed, v. This one has the angular speed, omega. And then this one has the period, or the time, for one complete cycle. So based on what the problem gives you, you may have to choose a different equation. Yes?
Can you see what the top one has one more time?
Can I see what the what?
Can you say what the top one has one more time?
The top one, yeah. This one has the tangential speed, the v, as in along the ground, which is the same speed. So if we were to take this bicycle wheel here, okay, and as we spin it, so based on how far away from the axis we are, the larger our r is. Given the same amount of rotational rate, the more r we have, the more v we have. So like, if you've ever been on a carousel, or it's fair time, so they often have spinny rides at the fair. Some of them spin you really, really fast, and you're stuck to the wall, and they even drop the floor out, and you don't actually fall because you're spinning so fast. It's like the gravitron or something like that. Yeah, super fun stuff. I used to do it, not anymore because my body, I'm 45 years old, and it just can't take spinning things a whole lot at this point. Coasters, I love playing some coasters, but even then, after like 5 or so, I'm done for the day. Speaking of coasters, yeah.
Oh, wonderful boy.
I thought you were younger. I thought he was like 30s. In his late 30s.
Well, thank you, thank you. So speaking of the Busch Gardens trip, I was hoping that the school cash online would be up today. I haven't checked since lunchtime, but the official price is $156.50. That includes our tickets in. We've got a nice bus to ride down in. We've got lunch in the park, including a snack. And then we've got a special custom physics t-shirt coming for you as well.
Who's the teacher?
Huh?
Who's the teacher?
Who's the teacher?
T-shirt. Oh, dude, I didn't even know about.
Custom physics t-shirt.
I'm gonna wear that every day for the rest of my life.
Let me enunciate. Yes. Jordan.
Oh wait.
He's like, what?
If we drive, are we allowed to drive or do we have to ride the
Oh
bus?
no, you gotta ride the bus. Yeah.
Yeah,
sorry.
be like the rest of us upstanding citizens, Jordan.
So
Oh,
as
okay.
soon as I know that the school cash is up, I will send you guys a message in rooms saying, hey, you guys can go on and pay. Remember, you've had to make a C or better in this class for the first 9 weeks. You guys get first dibs. If you didn't make the grades for the first 9 weeks and you have a C or better by progress support time in the second 9 weeks, you are able to go as well, as long as there's still room on the bus. Okay? I have permission slips in the copiers, so I'm assuming I will have those by Tuesday. But you can pay online and then turn in your permission slip later, as long as your parents are okay with that, because payment online saves your spot. Okay? Got it. When? In a couple weeks. Yeah, because we're in week 3 now. January 10th. It's that Friday after we come back from Christmas break.
I don't know, I was like average.
Yeah, you do.
What's that, guys?
You need to lock us on next time.
34.
How many what?
Nigga, that's 34.
Because I think it's week 3 right now.
Oh my god.
So
How is he gonna get
we
that?
should
She
get
was
it like
nothing in the grade.
kind of right before Thanksgiving.
It's week 2.
Well, everything's working the same amount of
Right now.
Right.
Is it?
She only puts in
I thought it was week 3.
It's week 3
Every
of
single
the
time.
third quarter.
We actually need 100.
We're almost
You
done
gotta
with
turn
it.
it every single time.
I mean, progress reports are about to come out soon.
I mean, like in a couple weeks.
You're cooked, yeah.
Yo, I'm ready to do this right.
Yeah. So week 1, week 2, we are in week 3. Yeah. So week 4 is next week. Week 5 is the full week before
We're looking at the
Thanksgiving.
Euro test.
So I'm guessing by Friday the 22nd, that's when the progress reports will be.
What?
I think. Well, after Thanksgiving,
A lot of things about the 30 years.
Christmas will explode up in
What?
That's better.
Oh yes.
Oh yeah, no, I got all the art stuff.
I love Christmas. I've got a whole Christmas
I'm pretty sure there should be one time.
village that's made out of Legos.
Like in the first row.
You gotta push that.
Oh yeah. Oh yeah?
You gonna see like a couple bees, like,
Yeah.
like first, like you
It
gonna see like, a couple
is
bees.
crazy epic. I've got a train.
Prepare for that.
around.
A train?
The track.
You have a train?
Yes.
You have a train?
I got a train.
Can I see a train?
Well, you'll see it once it's out.
Why can't I have a train?
When is it gonna be out?
After Thanksgiving.
Why?
Why not before?
Because I need the Thanksgiving time.
We should
Because
try to
one,
celebrate this holiday 2 different ways.
officially, the end of the Thanksgiving Day parade is when Santa arrives, and that is the official start of the Christmas season. Some people want to start early, and that's completely fine with them. If they want to start listening to Christmas music and decorate the houses early, okay? I know the stores are all like, boom, we're done with Halloween. Let's go on to Christmas.
At the moment, Halloween.
But there is a reason for that, though.
Halloween stuff in
Because the jollier the people are, the more in the Christmas mood, the more they spend.
That's so real. That's so real.
It's all about the money, guys. And that's also why, as soon as Christmas is over, we're like, we're done with it. Toss it all away. Okay. I like to extend it to, June.
Real.
It looks so funny. Cause they
January
pictures of it every single year like it's something new.
Because technically, the 12 days of Christmas, the first day is actually Christmas Day. And it
Bro,
goes
every
from
year I
that
put
to
it in a bad
Epiphany.
way back in the box, and then the next year I open it, I'm like, bro, why is it
How
like
long is she
this?
trying to creep up her Christmas tree until July?
We do that.
Oh.
We do that.
Take-
My sister-in-law kind of, she keeps her tree, although it's like as tall as this,
Bro, we were so lazy.
Roof
We
here.
didn't take down Christmas tree until January, end of
she
January.
keeps her tree up all year long. Well, because it's so big, it takes a lot of effort to take it down and to put it back up. She just left it on all year long.
I don't blame her. I really don't.
Hey, might
Wow.
as well.
It's like just sitting there.
It's gonna come back. It's gonna come back around anyway.
Yeah, one time we were
Like, I have like this big,
Yeah.
sitting in a tree.
Wow.
I just won't turn on the lights until
That's crazy.
And what's fun to get ornaments, you have to like go all the way to the top step and then just get over like this and leave it at the top.
I am imagining Buddy jumping onto the tree to try to put the star on top. But with that, like, you guys will jump off of your staircase and
Every,
that's funny.
every
But then the tree will fall. So.
New Year.
In July, I'm like, don't do that.
That's what we mean you sitting
Now,
there.
some people actually switch out the ornaments for the different seasons. So they'll keep their tree up, but then they'll put on like, pink ornaments for Valentine's, and then they'll do like 4th of July stuff for summer.
They got too much time on their hands.
Maybe.
I don't care about this.
All right, guys, let's keep rolling because we're almost done. So if we go back and we talk about the period, so the period is the time for one complete oscillation or cycle. If we invert that, we get something called frequency. Frequency. And frequency is the inverse of the period. So frequency would be the number of cycles that happen per second, whereas the period is the time for one cycle. So they're inverses of each other. Okay? In your books, although it does give you these equations, we'll actually talk more about these equations in a later a chapter even. They're not even in our A2 section, but they're found elsewhere in the equation sheets. But they show them here, so we're gonna real quickly roll through them. We also have, the angular velocity here is also related to the period and the frequency, as in 2 pi over the period, as well as 2 pi times the frequency, which again, we are going to use later on as well. The last thing that we need to talk about here is, a couple of things. So when that, we base this based on constant speed, okay? Constant speed going around a circular path, but what if we wanted to speed it up? So now we have the acceleration based on the going in a circle part, but then we also have a tangential acceleration due to speeding up. Remember that the acceleration that changes its speed, if it's aligned with the velocity, it's going to speed up. If it's opposite, it's going to slow down. So if I am swinging the ball on the string faster and faster and faster, I am increasing the angular and the tangential speed here. So the V is increasing. So we've got another, we're going to call this a tangential acceleration. Because we've got an object going around in a circular path, the X's and Y's are always changing. So it's often useful to look at it as a, well, let's redefine, this will be a tangential and then there's a radial direction, forwards and away from